All right, without further ado, Mr. Trutna here. We're going over Unit 12, Worksheet 2. We're talking about inscribed angles. So remember, the thing about inscribed angles are that they are equal to 1/2 of the intercepted arc. Okay? So we're always going to be halving something, which means we're going to be dividing by 2. Or we are always going to be doubling, which means we're going to be multiplying by 2. So if you notice in number 1, we want to find the value of x. Well, is x an angle or is x an arc? X is obviously an angle. And as you can see, the arc that's intercepted between the two sides of the angle is that angle right there. Therefore, that angle is 1/2 of that arc. Okay? So 90 divided by 2 is equal to 45. Number 1 is 45 degrees. Number 2, we're finding x. And if you notice, x right here, well, x is the arc. Well, that arc is the intercepted arc that's bounded by this angle right here. Okay? And that angle, which is an inscribed angle, and why is it an inscribed angle? It's because whenever the vertex of the angle is right on the border of the circle, that makes it an inscribed angle. The arc is twice as big as the angle. So 37 multiplied by 2 is equal to 74. So in number 2, x is 74 degrees. Okay? In number 3, we're finding the value of x. And if you notice that x is that arc right there. Okay, well, in this case, that arc, which I just outlined in gray, is not the intercepted arc of this angle. The intercepted arc that is bounded by the inscribed angle is that green arc right there. Here you can see, here is the inscribed angle. Okay, and that arc, that green arc, is bounded by that angle. Well, that angle is 50, so that means this green arc is equal to 100 degrees. Okay, so now the question is, how much is the gray arc? What's the measure of the gray arc, which is x? Well, this line segment right here, that is a diameter. So that means we have 180 degrees all the way around. So 180 minus 100 is going to give us our answer. So number 3, x is equal to 80 degrees. Okay, numbers 4 through 6, we're going to solve for the given angle. So in number 4, we want to find the measure of angle C. Well, angle C is this angle right here. And as you can see, the arc that is bounded by that angle, the intercepted arc, is 82 degrees. Well, that means that the inscribed angle is going to be half of that. So 82 divided by 2 is equal to 41. Angle C, the measure of angle C is 41 degrees. Okay, number 5, we want to find the measure of angle A. There's angle A. So angle A is an inscribed angle. There's the two sides. Remember, every angle has two sides. So the arc, that is the intercepted arc, that is bounded by the angle, is this arc right here. Well, I don't know how much that is. All right. However, you do notice that arc B to A is denoted as 125 degrees, and arc A to C is denoted as 75 degrees. And then if you notice, the three arcs, the green arc and the orange arc and the gray arc, they encompass the entire circle. So that means that if I took 75 and I added it to 125, that would give me 200 degrees. So that means this gray arc would be 360, an entire circle, minus 200. So this gray arc is 160 degrees, which makes angle A half of that. An inscribed angle is always half of its intercepted arc. So 160 divided by 2 is equal to 80. The measure of angle A is 80 degrees. Okay, number 6, we want to find the measure of angle C. Well, here's C right here. The two sides that make up angle C are those two sides right there. The intercepted arc bounded by the two sides of the angle are arc DB. Okay, well, we don't know how many degrees that is, but we do know that arc C around to D here, which I just outlined in green, is 140 degrees, which means that this arc right here has to be 40. Why do we know that? 140 plus 40 is 180, and you see C to B is a diameter. So that means that angle is half of its intercepted arc. Half of 40, 40 divided by 2 is 20. So angle C in number 6 is 20 degrees. All right, so number 7 through 9, we're going to solve for the given. All right, so we're going to basically, it says angle, but it's not necessarily an angle, because if you notice in number 7, it wants to know what is arc RD. Okay, well, here is arc RD right here. So R to D, we're trying to find that arc. Well, if you notice that that arc is bounded by this angle right here, which is 73 degrees. That's an inscribed angle. So that means the arc is going to be twice as big, 73 times 2, 146 degrees. So number 7, we get 146 degrees. Okay, in number 8, we want to find arc C to E. C to E. That is that arc right there that I just outlined in green. All right, well, I don't know what that is, but I do notice that I can find arc D to E. If you notice, arc D to E is bounded by the inscribed angle, so it's the intercepted arc of angle, that 25-degree angle. So that means that arc is 50 degrees. Remember, inscribed angle is always half of its arc. So you double the angle to find the arc. All right, now we say to ourselves, okay, well, how much is arc DE? 50 plus EC, that would be 180. So 180 take away 50 gives me arc E to C. So arc E to C is going to be 130 degrees. All right, number 9, we're finding arc G to T. So here's G, there is T. I don't know how many degrees that is, but you should notice that arc B to T is 120 degrees, okay, which I just outlined in orange. And arc B to G, if you notice, is bounded by the inscribed angle that is 70 degrees. So notice that angle right there. Intercepted arc is arc G to B. Well, if the angle is 70, 70 times 2 makes that arc 140. Okay, now if you notice, we've got 3 arcs that make up that encompass the entire circle. So 120 and 140, if I add those two up, that gives me 260. And then if I subtract 260 from 360, because 360 is an entire circle, I get 100 degrees. So arc G to T is going to be 100 degrees. Okay? All right, number 10, we're going to solve for x. So x is represented by this angle right here. So let's follow the two sides of this angle, of the angle that's marked as x out, and you will notice that the arc that is intercepted by that angle, that's bounded by that angle, is that arc right there. All right, so I don't know that arc, but I do notice that this angle right here is 62 degrees. So let's follow that 62 degree angle out. One side of the 62 degree angle goes to there. One side of the 62 degree angle goes there, and lo and behold, that 62 degree angle's intercepted arc is also that gray arc. Well, that is 62. So that means that arc is twice as big, okay? So 62 times 2 is 124. So that means that gray arc is 124. That means x is half of that. So in number 10, x is going to have to be 62 degrees. It turns out they're the same. Okay? Number 11 right here, now in number 11 we have an equation. So notice the angle that is represented by these two sides right here is represented by the mathematical expression 2x minus 12. And the intercepted arc of that inscribed angle is this intercepted arc right here, which is 200 degrees. Okay, so how does that help us? Well, if the intercepted arc is 200, remember the angle is half of that. What's half of 200? 100. So that means that angle right there has to be 100 degrees. So to solve for x, I create the equation 2x minus 12 which is what that inscribed angle is represented by, and it's equal to 100 because that's how many degrees it is, because that's half of 200. Solving this equation out, I add 12 to both sides. I get 28x is equal to 112, and then I divide both sides by 28, so x is going to be equal to 4. So number 11, x is going to be equal to 4. Number 12, we're given circle C. That means C is the center of the circle. We have diameter A to R. Okay, we know that the measure of angle HCA, so let's mark that, HCA, so that angle right there, which is right in the center, is 50 degrees. Okay, so let's calculate the following. The measure of angle HIA. Okay, so HIA, I'm going to need a lot of colors for this one. So here's H, goes to I, goes to A. So I'm trying to find the measure of that angle right there. Okay, well, how do I do that? Well, if you notice, that angle's intercepted arc is this arc right here. Okay, how many degrees is that intercepted arc? I don't know, but I can find it. If that angle's center is 50, that means arc H to A also has to be 50. And then you were told that A to R is a diameter, so that means halfway around a circle is 180. If that's 50, that means this arc right here, which I outlined in orange, has to be 180 degrees. Okay? Well, that arc is the intercepted arc for this inscribed angle, so that inscribed angle, angle HIR, is half of 180. HIA, excuse me, HIA. Whoops, I kind of messed that one up. So HIA, let me do that again. There's H, there's I, there's A. Oh, that's its intercepted arc is 50 degrees, so that angle is half of that. So that would be 25 degrees. Hey, that was a lot easier. Now let's find the measure of angle HCR. So there's H, there's C, there's R, okay? Oh, so HCR, well, that's 50. Right next to that, those two have to be 180, so this would have to be 130 degrees, which, by the way, would make this arc not 180, it would make it 130 degrees. So HCR angle is 130 degrees. Now let's find angle HIR. I think I already found this one. All right, HIR. Okay, that's the HIR. So that angle is half of 130. So that would be 65 degrees. 130 divided by 2. It's an inscribed angle. The last one, the measure of angle AIR. Okay, so where's A? Right here. I is there, R is there. So it's that green angle. So its intercepted arc would be this arc bounded there. Well, that's half of the circle. That's 180. What's half of 180? 90. So angle AIR would be 90 degrees. Alrighty, moving on to number 13. Okay, give the degree measure of the dotted arc for each diagram. So notice the dotted arc right here, which I'm going to outline in a pen so you can see it a little bit more clearly. It would be that arc right there. Notice that it is bounded by the angle in the center right here, which is 150 degrees. So that means the dotted arc would be 150 degrees as well. Okay? Then in the next problem, our dotted arc is right here. Okay? And notice that arc is bounded by, it's the intercepted arc for that angle right there. That angle is 60 degrees. That angle is an inscribed angle, so that means the arc is twice as big. So 60 times 2 makes the dotted arc 120 degrees. Okay? Explain the difference between central angles, inscribed angles, and the arcs they intercept. Okay? So the difference is central angles, okay, are the same as their intercepted arcs, okay, like in this first problem in 13a. So central angles are the same as their intercepted arcs, All right, inscribed angles are 1/2 of their intercepted arc. Okay, so that's the difference. All right. Number 14, what is the degree measure of the arcs? First one, arc D to B. So arc D to B is right here. Now, if you notice, we have a 52-degree angle right here in the center of the circle. Pull this up or zoom it in just a little bit. Okay, so remember, that's a central angle. So that means if I follow this angle out, its arc will be the same. So that means arc E to B is 52. Now, E to D, that's half of a circle. So 180 take away 52 will give me arc D to B. All right, and that is an 8, that is a 2, that's 128. So arc D to B is 128 degrees. The next arc DCB. So if I start at D, I follow the circle through C, and I keep going around to B. Notice it encompasses the rest of the circle minus that arc D to B, the orange arc right there, which was 128. So to find arc DCB, I would just take 360 and take away 128 from that. All right, and that would be 232. So arc DCB is going to be 232 degrees. All right, number 15, what is the value of x? Notice x is represented, we see it right here, it's represented by that angle. It's represented by the expression 11x plus 7. So if I take this inscribed angle here, and I follow the two sides of the angle out, notice that the intercepted arc of that inscribed angle is 80 degrees. Well, that means that that angle right there has a measurement of half of that. Half of 80 is 40. So to help me solve for x, I set up the mathematical equation 11x plus 7 is equal to 40. That angle represented by the expression is equal to 40 degrees. Solving it out, I subtract 7 from both sides. 11x is equal to 33. Divide both sides of the equation by 11. X is going to be equal to 3. Okay, and number 16, what is the degree measure of the arc? And the arc that number 16 wants is arc DEF. Okay, so let's outline DEF. It's always a good idea when you're doing this. Arc DEF, start at D, go through E, end at F. That's the arc that I'm trying to find. Okay, so how do I find that? Well, a couple ways. Notice right here I have an 82-degree angle. That angle is in the center. So that means if I follow the two sides of that angle out, its intercepted arc would be the same. So that means that arc is 82 degrees, which is part of DEF. Notice DEF is arc DE, which is 82, plus arc EF, which is, I don't know. All right, but I'm going to find it, and here's how. Well, notice this angle is 40. If I follow that 40-degree angle out, that means that its intercepted arc would have to be 40 degrees as well. So if you notice, I have this arc, which is 40. I have this arc, which is 67. I have this arc, which is 105. And then I have this arc, which is 82. So if I add all of those up, 40 plus 67 plus 105 plus 82, that gives me a total of not the entire circle, but it gives me the entire circle except for that part right there. Okay, so I'm going to add all these up. That gives me a 4. I'm going to carry the 1. That gives me a 19. I'm going to carry the 1. So that gives me 294. Okay, so that means arc E to F is going to be 360 minus 294, which is 66 degrees. Okay, so now how do I find arc DEF? Well, I add up 82 and 66. So that would be 148 degrees. So that is number 16 right there. Okay, number 17, what is the measure of angle T? All right, here's angle T right here. Let's follow the two sides of angle T out. One side is T to S, the other side is T to B. Okay, well, that means that the intercepted arc of angle T, which is an inscribed angle, would be arc S to B. That means that angle T is half of this arc. Well, how do I find that arc? Well, if we notice, this arc right here, B to T, is 110. This arc, T around to S, is 130. And if you notice the three arcs, the orange one, and the green one, and the gray one, they encompass the full circle. So I add up 130 and 110. That gives me 240. And then from that, I subtract 360. And that's going to give me my unknown arc, which would be arc BS. And I'm not BSing about this. 120. That arc is 120, so that means angle T is half of that, because an inscribed angle is half. So 120 divided by 2, angle T is equal to 60. Okay? Number 18, what is the value of x? Once again, we have in number 18 one of these equations that I have to do. Okay, so 9x minus 23 is the expression for this angle right here. This is an inscribed angle. The intercepted arc between that inscribed angle is this arc right here, which is 80 degrees. So that means how many degrees does that angle have to be? It has to be half of 80. So this angle, which is represented by 9x minus 23, has to be 40 degrees. So I create the mathematical equation 9x minus 23 is equal to 40, and I solve that equation for x. I'm going to add 23 to both sides. That's going to give me a new equation after the 23's cancel out of 9x is equal to 63. I divide both sides of the equation by 9. That gives me, after the 9's cancel out, that gives me a solution of x is equal to 7, and that's what I was trying to find. All right, number 19. In circle A, that means A is the center of the circle. Angle CBD is an inscribed angle. Okay, so let's find that. CBD is an inscribed angle, and it looks like that is 36 degrees. What is the measure of angle CDA? So let's find angle CDA. CDA. So that angle right there I'm trying to find. Okay, so how am I going to do this? Well, watch this. If I follow this inscribed angle out, its intercepted arc is the arc D to C. If the inscribed angle is 36, that means its intercepted arc is twice as big. So 36 times 2 is 72. So that arc is 72 degrees. Now, if you notice, if I look at this angle right here in the center, which is angle A, and I follow the two sides of that center angle out, its intercepted arc is also that same arc right there, which is 72, which makes that central angle 72 degrees. Okay? Now, A to C is a radius. A to D is a radius. So that means those two pieces are the same. So that means this triangle right here is an isosceles triangle. So now I can find angle CDA without a doubt. Here's how I would do it. I would take 180, subtract 72 from it. There's 180 degrees in every triangle. Okay, that would give me 108. Then I'm going to divide that by 2, because these two angles in an isosceles triangle, which are known as the base angles, have to be the same. So the correct solution would be 54C. Okay? All right, number 20, 21, and 22 we're reviewing. We're solving for x. And if you notice, number 20's biggest exponent is 2. Number 21's biggest exponent is 2. Number 22, biggest exponent is 2. So these are all quadratics. So in number 20, I am going to rewrite this equation. I'm going to make it equal to 0. So the way that I make it equal to 0 is I subtract 35 from both sides of the equation. So that would give me x squared plus 2x minus 35 is equal to 0. Okay? And then what I'm going to do is I'm going to factor this equation out. So remember, this is called a trinomial. So a trinomial, if it can be factored, factors into two binomials. The first terms are x and x. And then if you recall, we're going to take the last term, which is 35. We're not going to worry about the negative yet. And we are going to make a list of all the distinct pairs of numbers that multiply to make 35. So 1 and 35. 7 and 5. And that's it. Now, one of those pairs can be added or subtracted to make positive 2. All right? And it's going to be 7 and 5. Now the question is, because it has to be, I have to multiply to make a negative 35, it means my answer is negative 7. I have to make it a positive 2. So it's either negative 7 plus 5, or it's negative 5 plus 7. Which one adds together to make positive 2? Well, it's the negative 5, so it'd be x minus 5, and the positive 7, so we get x plus 7. Okay, so that means my solutions are whatever would make that first parentheses equal to 0, which by adding 5 to each side, it means one of my answers is x is equal to 5, and whatever would make my second parentheses equal to 0, which if I subtract 7 from each side, I get x is equal to negative 7. So my two solutions to number 20 are x equals 5 and x equals negative 7. Okay, that's called solving by factoring. Now we're going to go to number 21. Number 21, my equation's already been factored. So what I want to do is, to solve for x, I need to get rid of that power of 2, and I need to get rid of the minus 1. So let's get rid of the power of 2 first. How do you get rid of a power of 2? You square root both sides. When I square root it, that power of 2 cancels out the square root symbol. And then my equation becomes x minus 1 equals, and what's the square root of 16? Well, remember, it's positive or negative 4. Positive 4 times positive 4 is 16. Negative 4 times negative 4 is 16. Now I need to solve for x, so I'm going to add 1 to both sides. Okay? These ones will cancel out. I get x is equal to, and I'm going to come up with two answers. Positive 4 plus 1 would be one of my answers. Notice I have positive 4 plus 1, so that gives me x equals 5. And negative 4 plus 1 is my other answer, plus 1, so that's negative 3. So there are my two answers to number 21. Okay, number 22. Number 22 is not like number 21 because I don't have the quantity squared, so I can't just do the square root. And I can't factor number 22 because I have this leading coefficient. So I'm going to have to use the quadratic formula. X is equal to negative b plus or minus the square root of b to the second power, b squared, minus 4 times a times the c value, all divided by 2 times the a value. Remember, this is the quadratic formula here. And by the way, if you ever have a quadratic, which means it's the highest exponent of 2, you could always use this formula. So I could have used this formula for number 20 or for number 21. Okay, so what's my a value? So remember, my a value is 2. The a value is always the coefficient, the number in front of the x squared. My b value is 4. My b value is always the coefficient, the number in front of the x. And my c value is 1. My c value is always the number without a variable next to it. We call it the constant. Now, a, b, and c, that's only true if it's equal to 0. And it is. So now I'm going to substitute these numbers in. So negative b just means the opposite of b, which would be negative 4. Plus or minus the square root. B squared becomes 4 squared. Minus 4 times the a value is 2, times the c value is 1. Then I'm going to divide that all by 2 times the a value, and the a value once again is 2. Okay? So then remember, when we work out the quadratic formula, the first thing we do is we always simplify inside the square root. So what's b? We can do this in our head. B squared is 16. And then it's going to be 4 times 2 times 1, that's 8. So this is going to become 16 minus 8. And then I'm going to divide that all by 2 times 2, which is 4. Simplify this out. 16 minus 8 is 8. So I get negative 4 plus or minus the square root of 8, all divided by 4. Okay? Now, that's not my answer because I could make a factor tree out of 8. So 8 factors in the 4 times 2. 4 factors in the 2 times 2. So I am going to then work this problem out right here. Okay, so that means 8 becomes 2 times 2 times 2, and I have a pair of 2's. So that means my answer simplifies to negative 4 plus or minus 2 square root 2, okay, divided by 4. Okay, guys? So I have that right there. Am I done? Well, I am done, unless, look at these 3 numbers here. Can I divide them all by a number? Can I simplify it? Yeah, I can divide everything by 2. Alright? So, what's negative 4 divided by 2? That's negative 2. So I get negative 2. Plus or minus. 2 divided by 2 is 1. So that would give me just the square root of 2. I can put a 1 there, but I don't have to. Over 4 divided by 2 is 2. So there's my answer to number 22.